Hi, this is Mrs. May. Today we're going to be looking at solving systems with substitution. And we just took a look at how to solve systems for graphing. So this is just a second way of solving to find a coordinate point with two equations. So I would pause the video and write these notes, how to solve linear systems by substitution. Number one, we solve one equation for any single variable. The easiest way is either to put it to an x equals or y equals. And I'm going to show you how to do that in a minute. Second step, substitute the expression in for a solved variable. I'll explain that. And solve and check your ordered pair. So if you haven't stopped the video yet, stop the video and write those notes, please. So as we look at this first set of equations, we have this already set up in a y equals situation right here, this very first equation. So we've got these two equations, and when we've got this y equals, and we've got a y here, what you can do is take and substitute this portion of your equation and substitute it where y is located in your second equation. The reason you can do this is because this says y is equal to that. So you've got these two equations, and you can say, okay, I've got y is equal to 2 times x plus 5. So where this y is located, I can substitute in 2x plus 5. So if you look down below, you can see where I've done this. I have taken 3x, that's coming from here, and I'm writing in this new equation, this 2x plus 5 from where that y was located is now here, and I still have equals to 10. This portion stays here. So as you can see, I have the two equations, they're now combined, and the reason I can do this is because y is equal, and I can substitute it in there. So I've got this new equation, and how do I go about solving this? Well, we know that the associated property of addition says that I can move parentheses around, and I want to combine my like terms. I have like terms here. I've got 3x plus 2x plus 5 equals 10. I can move these parentheses over here, and I can say, okay, I've got 3x plus 2x. Well, 3x plus 2x is 5x. Still have my plus 5 is equal to 10. And then, moving my number to the other side, I now have 5x is equal to 5, dividing by 5, end up with x is equal to 1. Well, that's all great, but now how do I get my y? Because remember, we're trying to solve so that we have a coordinate point. So if that x is equal to 1, so I'm going to move back up to my original equation. If I say x is equal to 1, and that's the first part of my coordinate point, I've got 1. But I want to know what y is equal to. Well, I can substitute in x into either equation. I'm just going to do it into the first one. And I would have y is equal to 2 times 1, x is equal to 1, plus 5. Well, I know 2 times 1 is 2, and 2 plus 5 is 7. Now, this is telling me that x is equal to, or excuse me, that y is equal to 7. So I would now have a coordinate solution for these two equations of 1, 7. How do I check to make sure that it's right? We'll put it into the second equation that you have here. So substituting in for x, I've got 3 times 1, because x is equal to 1, plus y is equal to 7, and is 3 plus 7 equal to 10? Absolutely. So this checks. So this coordinate point of 1, 7 is my solution to this set. I'm going to erase them here. This coordinate point of 1, 7 is the solution of where these two equations are going to intersect if I were to graph this. I would have 1 and 7. Notice that in this set of equations, we don't have a y is equal to or an x is equal to, but I can certainly fix that situation. Notice that I have here, note that you need to set one equation to y equals first. You can also set it to x equals first, but I'm just going to say y equals just to be consistent here. So I am going to take a look at both equations and decide which one is better suited to get it to a y equals. Well, it looks like this one is probably easiest. It has the least amount of numbers attached. It doesn't have any numbers attached to the variable. So as we've got this, if I have x minus y equals 3, when I move x to the other side, that's going to give me a negative x. So now I have a negative y, because remember, this says negative y, or minus y is the same as negative y, is equal to negative x, that's a positive 3, so we say plus 3. And then I'm going to have to multiply through by negative 1. And the reason I'm going to do that is because I've got this negative y, and I don't want it to be negative y, I want it to be y equals. So when I do this, I now take negative 1 times negative x, this is just x by itself, and then negative 1 times a positive 3 is going to give me a negative 3. So I have now ended up with this equation, y is equal to x minus 3. So I'm going to move some things around here. And if you need to pause the video before I erase, go ahead and do that. I just want to get this moved up here. So when I've done this, I ended up with y is equal to x minus 3. So now I have this y equals situation. I can substitute in y. For y, I can substitute in x minus 3. So now I've got this new equation that I'm going to write using this equation. So I've got x plus 2 times y. Well, we said y is x minus 3 is equal to negative 6. Now, I have to do the distributive property before I can actually solve or combine anything, because I've got this 2 times x minus 3. So using the distributive property, I've got 2 times x, which is 2x, and I've got 2 times negative 3, which is negative 6, still equal to that negative 6. Now I can move around and I can do some combining. I've got x plus 2x plus 3x. I can move my negative 6 to the other side by adding 6 to that. 3x is equal to negative 6 plus 6, which is going to give me 0. Divide by 3. Obviously, I'm going to get x is equal to 0. So I've got this first coordinate point, or this first coordinate, x is equal to 0. As I'm erasing here. So I know that x is equal to 0, and I want to find out what y is. Well, I can substitute it into either equation, so I'm just going to do it to the first one here. If I say x is equal to 0, that gives me negative y is equal to 3, and when I move it to a y equals, that gives me y is equal to negative 3. So I've got this coordinate point 0, negative 3, and I can substitute this in to double check to make sure that I solved this correctly. So I can say, okay, x is equal to 0 plus 2 times y, which is negative 3, is equal to negative 6. And then let me do some erasing down here. I've got 0 plus negative 6 is equal to negative 6, and that is a true statement. So therefore, this is the true coordinate point answer for these two equations. So as you can see, when we've got these equations, and we're trying to find that intersection point. We've talked about the equilibrium point. We've talked about that intersection point. So this coordinate point is what we would call the solution for these two equations. Here's one more example problem. Notice that this is already set up in a y equals. That's beautiful. I don't have to do anything other than do the substitution where y is located. This gives me a new equation of x plus 2 times 3x plus 2. I'm substituting it for y is equal to 11. So I'm taking this equation, rewriting it, and rewriting it with the y equals 3x plus 2. So I still have to use that distributive property. I've got x plus 2 times 3x is 6x, plus 2 times 2 is 4, equals 11. X plus 6x is equal to 7x, plus 4 is equal to 11. The 4 over to the other side of the equation, so that now I just have my variable with 7x is equal to 7, divide by 7, x is equal to 1. So now I can take that back in, and I can substitute that back into my equation to see what y is equal to. So if I substitute in up here, I've got y equals 3 times 1 plus 2. 3 times 1 we know is 3, plus 2 is 5, so we've got, okay, y is equal to 5. But again, we can go back and double check that this coordinate point is true by putting into the x into this other equation. So we've got x is equal to 1 plus 2 times what y is equal to 5 is equal to 11. Make sure it checks. 1 plus 10 equals 11. That's a true statement. So here is my coordinate point 1, 5, and that is the solution for these two equations. Here's your practice problem for tomorrow. Notice that you have to set this into a y equals. So choose whichever you prefer and do the substitutions and come to class ready and prepared to discuss this problem.